I guess it's the top of the hour. So, welcome to our session, Instrument and Analyze OpenTelemetry Data. I am Daniel. I'm a Senior Developer Relations Engineer here at New Relic. I'm joined by Jack, who's also a Senior Engineer working on OpenTelemetry. And we will be joined by Alan, who's also another software engineer working on OpenTelemetry. And to bring you this awesome session around like sending data to New Relic and leveraging OpenTelemetry data for your applications. So today what we're going to go over is what is OpenTelemetry and its future, core concepts, and getting started in OpenTelemetry, as well as seeing a live demo and instrumenting an application in Java with OpenTelemetry, as well as .NET. So yeah, let's just get started. So yeah, what is OpenTelemetry? OpenTelemetry is an awesome new standard for instrumentation that is built by the open source community. So OpenTelemetry was formed by merging two other open source projects. So it was merging Google's Open Census project and the CNCF's Open Tracing project. And the goal of this was to standardize how you collect and send telemetry data to a backend platform. So the OpenTelemetry project consists of a bunch of APIs, libraries, agents, and a collector that captures traces and metrics from your application and services that you can send and analyze in an observability tool like New Relic. So something that's really valuable about the project is both the spec that includes like very set semantic conventions, for example, like what attributes to be present in the telemetry, what should be their name, metric types, etc., and an implementation to actually get that data into a backend platform. So yeah, why OpenTelemetry? Why should you care? So even though there's been like a really strong use of open source software in monitoring and observability, recently there's been a large increase in observability software that is open source because of the interest in like distributed tracing as well as adoption of a lot of very popular open source projects like Kubernetes. So according to a recent report by Gartner, by 2025, 50% of new cloud native applications will use open source instrumentation instead of vendor specific agents for improved interoperability. So, what this is fancy words for is basically saying that you can now avoid vendor lock in by instrumenting your application once and sending your data wherever you see best fit. So, this is great for end users because you can get really deep instrumentation because it's open source and developed and maintained by the larger community, as well as provides interoperability between different tools to get end-to-end visibility into your observability data. So yeah, New Relic specifically has been part of the Open Telemetry project since it was born in 2019, and we've been contributing to the specifications and the various components of it since then. In the summer of 2020, we also announced our full commitment to open instrumentation, which included open sourcing all of our instrumentation and standardizing Open Telemetry for our future offerings. So since 2020, we have released a number of components to effortlessly send your Open Telemetry data to New Relic and different experiences and visualizations to navigate through that data and integrations with the New Relic One platform to benefit from the capabilities it offers, like alerting, dashboarding, and anomaly detection. So yeah, so today we offer two ways for you to ingest data into New Relic. You can now send data directly to our OTLP ingest endpoint, which is currently available to everyone. And you can also use our OpenTelemetry collector with the New Relic exporter to send your data to our own APIs for traces and metrics. So with our New Relic One platform, which is an integrated single source of truth for all of your observability data, you can contextualize your OpenTelemetry data based on like golden signals and the distributed traces, database calls, external calls, errors, etc., etc. So it's really, really powerful. So what is OpenTelemetry in general? So OpenTelemetry is not one thing. It's a variety of components. So these include language-specific APIs and SDKs, as well as tools like the OpenTelemetry collector. So the OpenTelemetry specification defines like the data model of the telemetry data, like traces, metrics, and logs, as well as standard semantic conventions for attributing telemetry data. So all of the specifications, as well as the various components that make OpenTelemetry possible, is the entire OpenTelemetry project. So here are some of the data that OpenTelemetry collects and sends to your various backends. So the first type of data is called traces. So, what is a trace? So, a trace captures details of a single request through a particular system. So, a trace is made up of individual components called spans, which is a unit of work within a trace, like an HTTP call or a database call. So, each span contains metadata, which describes the operation, like the name, the start time, end time, etc., etc. So, for common operations like an HTTP call, a span's name and set of attributes should follow the OTEL's semantic conventions for it to be read properly by a lot of different backends. So the traces specification of OpenTelemetry is the most mature out of all of the different types of data, like metrics and logs. The specification has been declared stable and is a lot of companies use it in production. So yeah, super, super cool. The second type of data that OpenTelemetry supports is metrics. So the metric data is a little bit different than trace data because it represents pre-aggregated measurements that are useful for providing an indication of the availability and performance of your services. So an example of metric data includes things like system metrics, like CPU usage, memory usage, et cetera, et cetera. It's also really great for measuring request-specific information, like request-specific, like request duration, throughput, size, and error rate. So the OpenTelemetry Metrics API allows you to add metadata to your metrics in the form of attributes. So the selection of attributes to add to metrics should be considered very, very carefully. So the purpose of metric attributes are enabling you to facet your data in useful ways. So any attribute in a metric should be in a finite set of values. So OpenTelemetry's metric data model has been designed so it can be translated from other common metric systems and formats like Prometheus and StatsD. So this allows you to take advantage of any existing instrumentation you have and then use that and integrate it with other OpenTelemetry data sources. So talking about logs, so log data, OpenTelemetry support for log data is still very rudimentary. So all of the other, compared to all the other sources for telemetry data, so the challenge for OpenTelemetry and the log support is to integrate existing sources of log data with other telemetry generated from your application, like trace data. But OpenTelemetry has a couple of ideas to kind of solve this. So a lot of popular logging libraries for many languages are designed to be extendable. So one strategy for OpenTelemetry is to implement like appenders or exporters for these existing libraries. So these extensions could be then enable log data to be correlated with current trace data and span ID when a log is emitted. So also, it's really, really common for people to run a log forwarder like FluentBit in their environment. So if you're using a log forwarder, the idea is that you can also run an OpenTelemetry collector in your environment and forward your log data through it. So the advantage to do this is that the collector is a central location where you can enrich and process all of your data and all of your sources for telemetry data and centralize your means of exporting all of these data to one backend or multiple backends, which leads to our final kind of concept in OpenTelemetry, which is called the collector. So I think OpenTelemetry collector is one of the most exciting tools that OpenTelemetry has to offer because it's meant to run as a central place to retrieve, process, and export your telemetry data. So this is completely vendor agnostic and supports many of the open source formats for telemetry data. So the architecture of a particular collector centers around three different types of components. So it comes with a receiver for receiving telemetry data, processors for processing telemetry data, and finally exporters for exporting the telemetry data to a backend like New Relic. So just like the OpenTelemetry SDKs for each language, the collector is designed to be extendable and fit your particular use case. So if you visit the OpenTelemetry collector GitHub repo, there's already a lot of components that are already pre-developed that you can just plug and play into your environment. So for each data source, whether it's like traces, metrics, logs, you can configure a pipeline for processing that data. So common processors enable you to further filter, sample, or enrich your telemetry data into one location. And one of the key benefits here is that it enables systems operators who may not have access to the code to control the telemetry data that is emitted from their systems. So there's a couple of ways to actually get this data into New Relic. So the first way to deploy the collector is very simple. It's like a gateway. So in this configuration, all of your services would report data to a central collector, which would then forward the data into a backend like New Relic. You could also configure your collector so it sits in the particular environment like an agent. So it would be running in the same host as the service reporting data to it. So if you're running this in Kubernetes, you would run this as a sidecar or a daemon set to ensure that the collector is run on each node of your cluster in the pod. So one advantage of doing this, doing this way of a deployment, is to enable to collect telemetry data on like the system itself or the environment, like system metrics. And you can either report this data directly to the backend through the OTLP endpoint, or report data to another intermediate OpenTelemetry collector that's deployed as a gateway for further processing. So yeah, New Relic, like I said before, New Relic allows you to ingest data with a native OTLP endpoint, which enables you to run an OpenTelemetry collector and configure it to use an OTLP exporter to export data into New Relic. And of course, the endpoint accepts OTel's like native data format. Another option is to run your own OpenTelemetry collector. New Relic has developed its own exporter for the OpenTelemetry collector. So in this configuration, you'd have your service use the appropriate OTLP exporter provided by the SDK to send data to your collector, which then forwards the data to New Relic. So all the source codes and documentation is in the OpenTelemetry collector contributor repository in the OpenTelemetry GitHub organization. So yeah. But I would highly recommend using the OTLP endpoint to export data directly from your service because it's super, super simple to get started and get data reporting into New Relic really, really quickly. But without further ado, I would love to hand this over to Jack, who will now demonstrate how to instrument your application with in Java with OpenTelemetry and how you can start getting data of your Java application into New Relic. So yeah, take it away, Jack.
Thanks, Daniel. So my name is Jack Berg. I work here at New Relic on a team that is dedicated to furthering OpenTelemetry as a project. I specifically work on the OpenTelemetry Java project, and what I'm going to show you today is we're going to dip our toes wet in OpenTelemetry and take a simple Java application, add OpenTelemetry instrumentation to it, export that data to New Relic, and view that data in New Relic, just to kind of show you how simple it can be. So let's share my screen. All right, hopefully everybody can see that. So the application that we're going to instrument today is a Spring application. Specifically, we're going to use this Spring initializer. And what this allows you to do is it allows you to, in a UI, click some settings and generate a simple project template from those settings. And so, what we're going to do is we are going to say that we want to work with Gradle, because that's my preferred build tool. We're going to use, our language is going to be Java. We're going to use the latest version of Spring Boot 2.5.6. We're going to package this up as a jar. We're going to use Java 11. And the type of application I want to create is I want to create a simple web application. I want to expose a simple endpoint, and I want to be able to exercise that endpoint and see data flowing into New Relic ultimately. And so in Spring, the thing that makes that happen is Spring Web. And so I'm going to add that as a dependency. And then I'm going to generate this project. And we're going to go from there. Sorry, there's an overlay on my screen. Couldn't see what I was doing. So yeah, time to generate. So what this is going to do is it downloads a zip containing source that'll get you started with this project. And we can kind of see the structure of it. It's a typical Gradle project setup. I'm going to import this in IntelliJ, and then we're going to get started. So bear with me. All right, we are importing into IntelliJ. All right, so while this is importing real quick, let's explore. We got a build.gradle file. This is written using the Groovy DSL. And what we have is the Spring Boot plugin. This provides some Gradle tasks for running the application, for creating an executable jar. And it expresses the dependency on Spring Web, which is what's going to allow us to set up a web server really quickly. Over in our source directory in main, we have a class called demo application. This contains our public static void main, which is going to initialize the application. And if anyone is familiar with Spring, this should look super familiar with you. A Spring Boot application annotation allows Spring to automatically do a bunch of configuration to set this up. And it's basically going to introspect on the classes that are available on the class path and set stuff up according to that. Because we have our dependency on Spring Boot Starter Web, it's automatically going to do a bunch of configuration that sets this up to be a web project. And so, okay, let's try to run this just to make sure we're on the same page. So, okay, I'm in the right place. And the task that the Spring Boot Gradle plugin creates or adds to run an application is called boot run. And so if everything is right, if everything goes right, then running boot run, we should start our application and we should be able to navigate to that in a web browser and see it. Great, this looks like the typical logs of a Spring application starting up. We can see that we have a Tomcat web server that's been started on port 8080. And if I go over to my browser and navigate to port 8080, we'll see that we have an error page. And so this is kind of, this is typical of a Spring application. This is the white label error page, which basically means that a server's running, it's receiving our request, but it's not doing anything yet. So before we go ahead and add instrumentation, let's add a simple controller that we can call with an endpoint to exercise this. So I'm going to add a Java class. I'm going to call it controller. We're going to do this using annotations. There's also XML-based configuration for Spring, but I find that annotations are easier. I'm going to call this the REST controller annotation, which allows this controller to be picked up as a bean in Spring. And I'm going to add get mapping for the ping path. It's going to return a string, and the string that it's going to return when you call it is just going to be Pong. So you call get/ping, you get the Pong response. And so Spring Boot will automatically detect this based on the annotations, add an endpoint to its configuration, and route calls to get ping to this method. So let's prove that. So I'm going to stop my application and restart it over in my shell. Great, the application's running. And if everything went correctly, I should be able to navigate to ping now. And I see my Pong response. So great, we got a web application. It's we can call it and we can get responses. Let us go about instrumenting it with OpenTelemetry. So to start this, I'm going to go back to my build.gradle and I'm going to add some dependencies. So, you know, this is a demo. So I got some dependencies over on a different screen I'm going to paste in. And let's talk through these real quickly. So the first two things that we've added are platform dependencies on what's called the OpenTelemetry BOM and BOM Alpha. And what BOM stands for is Bill of Materials. And so what these essentially do is these manage, I mean, there's bills of materials for other projects. There's bills of material for Spring as well. But it's version management for artifacts that are under the OpenTelemetry umbrella. And so by expressing dependencies on these bill of materials, we don't have to express versions on the individual artifacts that we're bringing in. That's going to happen automatically. And so that just helps keep your dependency versions in sync. The first kind of real concrete dependency that we have is going to be on what's called the OpenTelemetry SDK extension auto configure module. And what this does is this allows us to set up the OpenTelemetry SDK using system properties and environment variables. The alternative to this is that you can do programmatic configuration. So, you know, you can build out the OpenTelemetry SDK using code. But for demonstration purposes, we are going to use the auto configuration module and system properties and environment variables. So ultimately, we want to take the telemetry data that's generated and get it out of the application. And so to do that, we need exporters. And so what we're going to do is we're going to add trace and some metrics. And so we need a trace and metric exporter. And that's what these two dependencies are on here. So these two dependencies are the trace and metric OTLP exporters. And what that means is you can export trace and metric data using what's called OpenTelemetry Protocol. And that's what OTLP stands for, OpenTelemetry Protocol. And in case you're not familiar, OTLP is it's a standard way to represent telemetry data and send it over the wire. So there's a variety of protocols kind of inside of that, but it's typically HTTP or gRPC based, and the message format is protocol buffers. So it's like a binary encoding. There's also a JSON representation, but we're not going to talk about that. For our purposes today, we are going to export data over gRPC, and gRPC operates on protocol buffers, that binary format by default. So we're going to use gRPC, right? So we actually need a gRPC client library to act as the transport for that. And so here, I've brought in gRPC netty shaded and version 1.41.0. And this is what these exporters will use actually as the gRPC implementation to send data. So a couple more dependencies that I'm going to paste in here. These kind of allow us to configure the SDK to decide what to do with the data, but I also want to generate some instrumentation data, and that's what these dependencies that I've expressed here are. So there is an additional BOM for OpenTelemetry instrumentation, so an additional bill of materials, and I've brought that in here, and that will allow me to express dependencies on instrumentation libraries that are published as part of OpenTelemetry without having to manage their versions explicitly. So the two pieces of instrumentation that I'm going to bring in are OpenTelemetry runtime metrics. And what this is going to do is this is going to add instrumentation for JVM memory usage and garbage collection. So that'll be nice. And also I'm going to bring in what's called OpenTelemetry Spring MVC 3-to-1. And what this is this is going to add instrumentation to our Spring Web MVC server. And the way it's going to work is it's going to provide a servlet filter that we can add to our filter chain. And when we do that, what that filter is going to do is it's going to be able to intercept HTTP requests on the way in and out of our application and be able to set up some tracing and some metrics based on those calls. So at this point, we have all of our dependencies in. Before I go further, I'm just going to click this Gradle refresh button here, and I'm going to go back to my shell and rerun the application just to make sure I haven't screwed anything up.
Hey, Jack, I don't mean to interrupt your flow, but there was a request to make your font bigger if you can in IntelliJ.
Ooh, yeah. I don't do that very often, but let's see. That's window, zoom. How do I do that? So that's probably too big. Whatever, though, it's better, right? Let's see if I can do the same in the terminal. No. That didn't work. There we go. So the terminal is now bigger too. Okay, so I reran the application in the terminal and nothing broke. So presumably that means things are working. Great. But I mentioned before that we are using the SDK extension auto configure modules so that we can do, well, actually, let me backtrack. So we've added these dependencies. Now I need to actually go ahead and add the code that allows these two pieces of instrumentation that I've added to actually function. So that won't happen automatically in this case. There is a Java agent that's published by OpenTelemetry, which will automatically add instrumentation code to your application, but that's not what we're doing here today. So what I need to do is manually set up a few things. So first things first, the first thing you should do in any OpenTelemetry application is configure your OpenTelemetry SDK as early as possible. And so I've added this line here as the first thing we do in our public static void main. And what this is going to do is this is going to set up an OpenTelemetry SDK based on system properties and environment variables. And we'll link out to the docs for that at some point, but suffice it to say that there's a bunch of system properties and environment variables that you can do to configure exactly what happens with your SDK. The next thing we're going to do is we're going to leverage this OpenTelemetry runtime metrics dependency, and we're going to add some instruments based on that. So what I've done here is I've added calls to memory pools, register observers, and garbage collector register observers. And this is going to set up metric instruments that monitor our JVM memory pools and our JVM garbage collection. And it's going to, send those out whenever we export metrics. So the final thing I mentioned is that we are going to use this OpenTelemetry Spring Web MVC instrumentation, and that comes in the form of a servlet filter. And so the way that I'm going to add that servlet filter to our filters chain in Spring is I'm going to add a bean, and I'm going to say that this is a filter. Let's import filter first. And the call that I'm going to make to define the filter is this right here. So this is a static method that's provided by that OpenTelemetry Spring MVC dependency. And what it does is it takes as an argument an instance of the OpenTelemetry, of the OpenTelemetry SDK. And so I'm going to call this global accessor called global OpenTelemetry get. And what this is going to do is this is going to return the SDK that was initialized by this auto configure module. So, I can use environment variables and system properties to configure the SDK, and then I can obtain that programmatically, pass it to this, this function, and then create a new servlet filter from that. And so, assuming I've done everything right, we now should have an application that is instrumented with some JVM runtime metrics, and which has a servlet filter added to its filter chain so that we can get some tracing and metrics about calls to the HTTP server. So just to confirm again that I haven't broken anything, I'm going to rerun my application. But I don't expect anything to happen yet, because while I've added the instrumentation code, I haven't actually configured what to do with the OpenTelemetry SDK. I need to set up some environment variables to dictate exactly what the behavior is. Without these environment variables, the data is just going to be dropped on the floor. And that's the intent. Is so the instrumentation code shouldn't do anything until you configure the OpenTelemetry SDK to instruct it what to do. So yeah, let's stop this application and let's set up some environment variables, and we'll walk through exactly what they do. So the first one I'm going to do is this one, OTel exporter, OTLP endpoint. This instructs the OpenTelemetry SDK to export OTLP data to this endpoint, this is the endpoint that New Relic provides to ingest OTLP data. So export. The next one that I'm going to add is OTel metrics exporter equals OTLP. So by default, tracing exports data over OTLP, but metrics, because they're still work in progress in OpenTelemetry, doesn't export data at all by default. And so this just turns on metric exporting and says to use OTLP. The next thing I'm going to do is I am going to set up the interval on which we export metrics. And so the default is 60 seconds. I want to change that to 1 second, or 1,000 milliseconds instead, so that we can see data faster. You might not need to change this. I am, because this is a demo. So finally, or not finally, but another thing that I need to do is over in a separate tab, I need to add an API key so that when we export data to New Relic, it can be properly authenticated and get to the account that we want it to. So, we don't share secrets. So I'm going to switch this over to a tab that hopefully you all can't see, and add my API key, and then clear my shell and bring it back. So trust me, I set up an API key environment variable. You'll just have to take my word for it. The final thing that we're going to do is we're going to set up some attributes that we are going to attach to our OpenTelemetry resource. So if you're not familiar with OpenTelemetry, a resource defines a software entity that is producing a particular set of telemetry data. And a resource consists of key value pairs. And so the key value pairs that we're going to use to define our resource, our software entity, is we're going to give it a service name. This is a required resource attribute that all applications must include. And we're going to call our application my test service. And then we're going to also add another attribute called service instance ID. And so the point of service instance ID is to uniquely identify this particular instance of software that is generating the telemetry data. So, if you have a replica set, each replica in that set would have a unique service instance ID. And we're going to need that for something later. So at this point, I have all my environment variables set up, and I should be able to run my application. And it's running. And if I go to my browser now, I can exercise this. And I can go, if I did everything right, demo gods, then I should be able to see data being exported to New Relic. And I'm going to go cross my fingers and hope I did everything right. So over here in this tab, I'm in my account in New Relic 1. And if your applications are emitting data via OTLP, you'll see them produce entries in this services OpenTelemetry section in the Explorer. So if you recall, the service name we assigned via environment variables was my test service. And here we see that it's showing up, and looks like we have some throughput and some response time data. So that's good. And if I click into this, I can see a summary of stuff. And, let's see, I see response time. I see some data there. I see throughput. I see error rate, all cool things. Great. It looks like data is getting into New Relic. One thing I should mention is that these dashboards, they are based off span data. And if you're new to the observability space in general, I guess if you're not new, you would know that spans are often sampled. And so what that means is that if your spans are sampled, then this data can be incomplete. So like if, for example, your application is producing one trace for every single HTTP request you receive, and you're receiving thousands per second, that can put a lot of load on both your application to emit all that trace data, and also on New Relic, which has to receive and make that all visible for you. And so samples are often sampled to reduce traces are often sampled to reduce the data overhead. And as a result of that, this data can be incomplete, right? It can be inaccurate. Now, the goal in the future is to have these panels be driven off metric data. But as of now, because metrics are a work in progress in OpenTelemetry, we get what we get. Traces are more mature than metrics, so we use traces to provide like a best guess at what these this information should be. Eventually, we will transition to metrics. Another thing I want to point out in here is, and this is the last thing actually, is that we can see our JVM runtime metrics that we added. And so if you recall, we added a resource attribute called service.instanceID, and we assigned its value to be 1, 2, 3, 4. And so that value, it manifests here. This is how, if there was multiple instances of our application running, we'd see multiple rows here, one per JVM instance that was associated with that same service.name. So we only have one here, but if we click on this, we can see some data about our garbage collection usage, about our memory pool usage, both heap and non-heap, and it's faceted in a variety of interesting ways. So that kind of wraps up what I wanted to show you today. So, we're just kind of scratching the surface of what you can do with OpenTelemetry. If you're new to this, hopefully you learned a little bit. And yeah, so that kind of wraps up what I wanted to share. So I will pass it back to Daniel, and we'll go from here.
Yeah, super. Thank you so much for the demo. That was really, really helpful in instrumenting our Java application with OpenTelemetry. But now we have Alan, who's going to show us how to instrument our .NET applications with OpenTelemetry. So Alan, whenever you're ready.
Hey, folks. Thanks, Daniel. Thanks, Jack. Yeah, so I'm going to go through a very similar flow that Jack just went through. I'll share my screen here in just a second. But with .NET, just to so you can kind of compare and contrast a couple of different languages. Let's share screen. And hop over to the terminal window. So I can't see y'all anymore. If people can't see my screen, please let me know. But I think you should be able to see it now. So to get started, I have the .NET SDK command line utility installed. If you happen to be following along, or you want to follow along later, you can download that from just search .NET download, and you'll be able to do that. I am running a preview version of, or release candidate version of .NET, the .NET 6 SDK. If you're running like the current .NET 5, the code that I'm about to generate here, the sample code I'm about to generate here, might look a little bit different just because of different SDK versions. But the gist should be the same regardless. Exciting news in the .NET world. .NET 6 should be released next week by Microsoft, so I'm excited about that. So to get things started, for the demo today, I'm going to create a new web API application. So it's going to create an ASP.NET Core application with a very simple REST API that returns a weather forecast. It's a single endpoint, and it returns a random 5-day weather forecast. This is all sample code. I didn't do it. It's just out of the box .NET SDK sample application. So if I look here, sure enough, I have some code here. I'm going to open this up in Visual Studio Code. And to get us going, let me open up a terminal window here. So to get us started, I'm going to open up the CS_proj file. Now, Jack's Java demonstration, this is kind of similar to a CS_proj file. It's kind of similar to the Gradle file in the sense that it's where you would declare the dependencies that your application has. So I'm going to do just as Jack did. I'm going to add a number of dependencies that are important for us to instrument this application with OpenTelemetry. So again, I'll use the .NET CLI, and I'll add a package. I'm going to use the pre-release switch. And the reason why I'm going to do this is because the OpenTelemetry NuGet packages, NuGet is the package manager in the .NET space, the pre-release versions have metric support. The stable versions don't currently. They only support traces. But they're pretty stable at this point in time. The OpenTelemetry project is going to come out with a release candidate of the SDK and so on shortly. I would say probably in the coming weeks, like after kind of the .NET 6 release next week. So the first thing I'm going to add is the OpenTelemetry SDK package. You'll see this update my CS_proj file in just a second. Sure enough, let's pull down a pre-release version, so 1.2.0 beta 1. That is the SDK. Next, since this is an ASP.NET Core app, so ASP.NET Core being kind of the big web framework in the .NET space, I'm going to add an instrumentation package that will enable auto-instrumentation of ASP.NET Core applications. So go ahead and add this one. And then ultimately, again, just like Jack did, he exported data from his Java application to New Relic using the OpenTelemetry protocol. I'm going to need to add the OTLP exporter for .NET. So that is if you recall, small difference here between Java and .NET. Jack's demonstration had two packages, the metrics package and the trace package for the OpenTelemetry protocol pack. But so long as you're using the pre-release version here, you will get both trace and metric support in a single package. So all I got to do is add that. And then I'm going to add one more package. So ASP.NET Core relies pretty heavily on Microsoft's dependency injection framework, and for configuring your application and dependencies and so on. So OpenTelemetry has an extension package called extensions hosting that provides some helpful extension methods for configuring OpenTelemetry in the context of an ASP.NET Core application. So that's going to be the last package that I add to this application. And then I'm going to do a .NET restore, just make sure all the dependencies got pulled down. Do a .NET build, just to make sure that things actually work. Great. So now let's go take a look at the code. Collapse that screen. Hop over here to program.cs. So this is the file where I'm going to do all of the configuration. It's where all the configuration of my service is, setting up the various controllers, endpoints, and so on. This is where I'm going to configure and bootstrap OpenTelemetry. Another point of comparison here between Java and .NET. Jack mentioned earlier that in his demonstration he used environment variables to configure a lot of the OpenTelemetry SDK in the context of his application. That is also possible with the .NET SDK, but just for fun, I'm going to do everything programmatically in the context of this application, just to show you there are a variety of different ways to achieve the same needs. So I have a handle onto my web application builder here, and because I added that OpenTelemetry extensions hosting package, I get a number of extension methods off of the services collection. Specifically, these are the two that I'm interested in: add OpenTelemetry tracing and add OpenTelemetry metrics. So that will enable me to configure both my tracing and my metric pipeline within my application. I'm going to start with tracing. So let's do this. This method takes a delegate that takes a tracer provider builder, and it is with the tracer provider builder that I will configure my tracer provider for my application. So I'll start with here, it's a builder, so I'll say builder dot, and then I'll do a number of configuration pieces here. I'm going to pause there for just a second before continuing on with configuring tracing. I'm going to add a couple of using statements up here. Let me add two. So I'm going to add OpenTelemetry resources namespace, and I'm going to add trace namespace. Looks like I spelled something wrong, so I added these because top level here, I'm going to configure a resource. So again, if you recall, in the Java application, Jack configured his resource, same concept here, with the environment variable, the standard OpenTelemetry environment variable, which I think is OTEL _ resource _ attributes. I think I read about that. So, but again, doing this programmatically in .NET, I am going to declare a resource. It's hard. I'm going to declare a resource builder. And there is a resource builder class within the OpenTelemetry resources namespace. That's why I added the using up above. And there's a static method here for just creating kind of an empty default resource. However, I'm going to continue here. And I'm going to use the builder method add service. So again, similar notion here. I'm going to, with the add service method, I have the ability to set a service name, service namespace, a version. A lot of these are optional, and a service instance ID, which if not specified, it'll just automatically generate one. I think it's just a GUID. We'll see that in a moment. But I'll call my service, how about Data Nerd Days? And then, other things that I can do here with my resources, I can add arbitrary attributes. So, maybe there's specific things, metadata about my environment or my service that would be relevant to see on all telemetry that's shipped up from this service. I can add arbitrary attributes, maybe like an environment, like production versus staging or something, things akin to that. So that's I can do that. But the last thing I'm going to actually do is call this add telemetry SDK. So what this does is it adds a suite of standard attributes defined within OpenTelemetry's semantic conventions. The attributes are, let's kind of comment them out here. They all start with telemetry dot SDK, and some of the ones are like telemetry SDK name, language, version. It's a whole suite of attributes. So I'm adding this because while not strictly necessary, it is going to become important, particularly for New Relic's user experience. So, Jack shared with you the JVM page. It wouldn't make sense for that JVM page to show up in the context of the .NET application. So the reason why that page shows up is because his application was sending up the telemetry SDK.language attribute so that New Relic could present you the correct experience. So while, .NET has a very similar thing like JVMs, it's got the common language runtime. We don't have an experience for .NET yet, but we will in the future. It'll be important that you add these attributes. So that's my resource. So now coming back down and continuing to configure my tracing pipeline, I am going to set the resource builder. So for all traces that are generated from this application, I want them to be decorated with the attributes that I've configured via the resource builder that I just did up above there. And then I'm going to add some instrumentation. So if you recall, I added the ASP.NET Core instrumentation package. All I got to do is just that one line, though. Just as a note, a lot of the auto instrumentation provided by the .NET SDK does have some additional options that you might want to explore. The options enable you to do things like, at least here in the context of the ASP.NET Core instrumentation, allows you to filter things arbitrarily. It takes in an HTTP context object, so you can arbitrarily filter requests if you so choose. An indication of whether you want to record exceptions, when exceptions bubble up out of your endpoints, and so on. But I'm going to keep this simple. I'm not going to actually declare any options. I'm just going to go with all the defaults here. Just wanted to share that with you. And then lastly, I'm going to configure our OTLP exporter. So I want to send data to New Relic. So I am going to be explicit here. Again, this is all configurable via environment variables as well, but just in the spirit of doing this programmatically, I will set the options here. So the first thing that I need to do is the endpoint, and the endpoint for sending data to New Relic via OTLP is https otlp.nr-data.net, and then the standard port for OTLP is 4317. So, and this is not a string, it's actually a URI object. Initialize. And then lastly, I'll need to authenticate with New Relic, right? So I'll need to supply an API key. So just as Jack did in his Java application, I need to have a string here. These are going to be headers that are passed along with every gRPC request that is made to New Relic. So it needs to take the form API-key equals, and then your key here. So again, in the spirit of not sharing my secrets with you, I'm going to just cheat here a bit, and I actually do have to set an environment variable, but I will just set up here a string here. So environment variable. All right. stored it in the standard named OTEL exporter OTLP headers environment variable. So that environment variable has the string of this form API key equals, and then it has my key. So that's it. I've configured tracing for my application. Metrics, almost identical. So I will just cheat here, and I'm going to copy this block of code here. I'm going to paste it down below. I'm just going to fix a couple things up to show you how easy it is to get both traces and metrics going in this application. So there is an add OpenTelemetry metrics extension method off of the service collection. It similarly has a meter provider builder that I have here. It's red squigglies because I need to add an additional using here to make that those extension methods available. So I'm going to add the OpenTelemetry metrics namespace, and sure enough, it fixed the red squiggles. So that's it. Code works as is, though I need to do one more thing. Right now, currently, New Relic only supports metrics over OTLP in what's using an aggregation temporality of delta. So that was a mouthful, but let me just type this out here. So for metrics specifically, I have to set this aggregation temporality option. And I have two choices, cumulative and delta. New Relic currently does not support cumulative. You must set delta in order for metrics to show up in New Relic. If you don't do this, then they'll be dropped on the floor at the front door of New Relic, and you'll get an NR integration error that you'll be able to query and troubleshoot and so on with. This is a subtlety. I'm not going to describe aggregation temporality in great detail here, but there is phenomenal documentation about aggregation temporality within the OpenTelemetry specification repository. That said, New Relic is working on supporting cumulative metrics, so that is something that's coming up here in the future. That said, that's it. I have traces, I have metrics configured. I could go on to show you logs, but you know what? This code is going to be available for you, and you can look at it later. I'm just going to do traces and metrics for right now. So let me pop open my console window again, and I'm going to make sure that things still build. One moment, please. There we go. Built. So now I'm going to run my application. Yes, developer cert. There we go. Right. So great. So application is up and running, and it's listening on localhost 7109. This application, like I was saying earlier, presents one controller weather forecast. It's got one endpoint that returns a random 5-day forecast. So I can pop over to a browser window. And head over there. Oh, that's fine. Weather forecast. There is my random weather forecast. Temperature -12 degrees. It is scorching. So there you go. Not very useful. I'm going to close that. I, unlike Jack, don't subject myself to the demo gods. I already have some data, so I cheated a little bit. I've had this application running in the background using JMeter. But popping over here to the New Relic Explorer, I'm looking at my account. I'm looking at my OpenTelemetry services. Sure enough, I see the Data Nerd Days OpenTelemetry service here. Great. I can pop into that, and I have data. So again, I'm going to show you a few more things here. So you saw this in Jack's demo. one thing he noted was that this overview page right now, because traces are the most mature data type within OpenTelemetry right now, this overview page is span-based, even in the context of this .NET application, even though I am sending metrics from this application as well. But I'm going to share with you some interesting things here. So I can pop over to my metrics explorer. Right now, New Relic does not have a curated experience for OpenTelemetry metrics just because they're just so cutting edge. But that doesn't mean you can't begin to use them. So if I look at the metric explorer here, you'll see that the application generates an HTTP server duration metric. In the application that's running pre-demo, I'm also making an external call, and it's generating an HTTP client duration metric as well. I'm using the HTTP client library to make that call. But I can look at the server duration metric, and sure enough, here's a metric that resembles my response time. Again, if I were sampling my spans, then I would expect to see a discrepancy between what the HTTP server duration metric here is showing and the sampled span data on the overview page. I'm gonna do something interesting here though. I'm gonna create my own dashboard because again, we don't have a curated UI, but that doesn't mean that you can't use this stuff already with New Relic. So I have a dashboard that I think I call Data Nerd Days, and I'm gonna call this chart response time. I'm going to copy that over to my dashboard. Before popping over there, this HTTP server duration metric, just kind of looking at the NURCL that generated it, it takes an average of the HTTP server duration, so it should resemble my response time. If I just change the aggregate function here to be a count, I should get the throughput of my application. So, similarly, I'm going to add this as well to the dashboard, and I'm going to call this if I can spell it right. But I will also add this to the Data Nerd Days that I had. Now I'm going to pop over to this dashboard and I'm going to show you. We're almost at time, but I'm hoping to show you that. All right, so ignore the top three charts for a second. I just duplicated the data on the overview page. These bottom two charts, these are the ones that I just added. The first one, which is based off of the average of the HTTP server duration metric to calculate my response time. And then the throughput here, where I changed it to count the HTTP server duration metric. You'll see here that, they do look, the hills and the valleys look pretty similar between the metric and trace data. Again, this is because I am sampling 100% of my spans. So that's why, that's just something to be cognizant of if you're not sending metric data. I'll just close this out. The error rate is based off of something that is from the perspective of span data. If I just open up and view this query, I hope this is big enough for you to see, but it is based off of a specific span, a specific attribute off of spans called the status code. This is going to be an interesting challenge for us to resemble error rate in a meaningful way using metrics, because there is no general error rate metric in OpenTelemetry terms today. I don't know if there ever will be, but I could create a chart similar to this, maybe in the context of this, since it's an HTTP server. I could create my own error rate chart, maybe based off of like the HTTP status code. I could write my own Merkle query and filter by the status codes that I'm interested in, maybe status codes above 400 or 500 or whatever.
Thanks, Alan, so much for your demonstration of the .NET plus OpenTelemetry integration and how that would work. But yeah, thank you so much for coming to our session. We went a little bit over, but we have a lot of awesome other exciting sessions coming up today. And to get a free New Relic account, just go to the link in the chat. It's trynewrelic.com/datanerddays to get a always free New Relic account where you can well, not always free. It's forever free tier New Relic account where you can try out all the things that we talked about in today's session in New Relic. So yeah, thank you so much, everyone. Have a great rest of your data nerd day.